Okay, so here's the reaction between but1ene, hydrogen, and our product is going to be butane. So let's look at how the reaction happens. First of all, notice that this reaction has got 2 reactants and 1 product. That's a classic sign of an addition reaction. And when you're analyzing just reactants, one of the things that you want to look for as a sign that we're a good candidate for an addition reaction is that we have 2 reactants, first of all. One of them has to be unsaturated. So my butene here has got a double bond between carbons 1 and 2. That's going to make this a good candidate for an addition reaction. It's going to be a good spot for this little diatomic hydrogen to come in and to react with it. So if the butene and the hydrogen are floating around in the same area, right, the molecules are going to be colliding. They're going to have chances to interact with each other. Now, if the hydrogen bumps into the butane over here, there's going to be a very low probability that it's going to react, because these single bond electrons are not particularly reactive, and the hydrogens up here are taking up space, and they're making it physically a little bit tricky for the hydrogen to come in and to attack this molecule. But on this side of the molecule, it's another story. We've got this double bond here. These electrons involved in the double bond are more reactive than the single bond electrons. And secondly, we also have more space. Take a look at this molecule. It's open on this side and it's open on this side. Those are both good spots where the hydrogen can come in and react. So the hydrogen is not going to bump in like this. Well, it might, but it's not going to react. The collision that we care about is when the hydrogen comes in with the correct orientation across this double bond here. And as it comes in, it can cause this double bond here to break. And as the double bond breaks, then that can also cause this single bond holding the hydrogens together to break as well. And as these 2 bonds break here, these electrons are going to desperately search for somebody else to bond with, right? They want to share their electrons, complete their octets, and get nice and stable. Well, who's the nice candidate? We've got a hydrogen sitting over here. It can bond with this carbon, complete this carbon's octet. These electrons are now going to be happier than they were before. And this hydrogen is sitting over here. It can bond with this carbon over here. And so the 2 hydrogens are going to latch on and bond, single bond, with the carbons that they were right next to as this collision happened. And we see now our 1 product, our butane here, that is going to form as a result. So we started with 2 reactants, an unsaturated butene and a hydrogen, and we end up with a saturated butane as our product. So what does this look like on paper? We are doing an addition reaction. We have the 2 components that we needed. We had an unsaturated hydrocarbon. In this case, we had an alkene, and it was reacting with a small diatomic molecule. In this case, it's hydrogen. So we have our butene, but1ene here, and our hydrogen. And I'm going to write it out as HH instead of H2 because it makes it easier to see what it's doing, right? The hydrogen is coming in over here. It's adding across this double bond, and when it does that, it breaks the double bond and forms butane. And we'll leave these hydrogens in red here so that you can recognize where they ended up. Okay, those are the 2 hydrogens that were a part of my little diatomic hydrogen coming in. So that's a really basic addition reaction. The next 2 examples will be a little bit more complicated. Now, what about the reaction between ethyne and bromine? If I look at my ethyne molecule, it's got a triple bond between the 2 carbons. And that is a very reactive bond. We've got lots of these electrons. They're very exposed. They're very reactive. They're going to want to react with a nice diatomic molecule like bromine. So these guys, we're using the greens for halogens. This is a bromine molecule here. So as the ethyne and the bromine are floating around, again, if they come into contact in the incorrect orientation, they're not going to react. But the bromine can come in like this, and as it encounters the ethyne, it can cause the triple bond to break, and that's going to cause the the bromine is going to be sitting right here. So the bromine can latch on and form a new bond with my ethyne. And so the result of that is going to be this molecule, which is still unsaturated, right? It still has a double bond here, but now it's got two bromines. It's got one bromine on this carbon and one bromine on this carbon. So this would be 1,2 dibromoethane. And sometimes when people are doing this reaction, they'll incorrectly put the two bromines on the same carbon, right? They'll say, what's the product going to be? And the product here will be 1,1-dibromoethene, with both of the bromines attached to this carbon on the end here. But you can see why it's not that way, because if I want to end up with both bromines on one of my carbons, that means I actually have to take off this hydrogen. I have to move it over here, place it onto this carbon here, and then I have to line up both my bromines on this carbon. And that's not going to happen. This hydrogen is perfectly happy over here on this carbon. He's not going to want to jump over to this carbon here. So that's why as the bromine comes in, it's going to add across the double bond to give us 1,2-dibromoethene. Now, you notice too that I've stopped here. This would be the product of this reaction. If there was more bromine present, it could add again. It could do another addition reaction to this molecule. But if there are other ethynes floating around, they're going to be more reactive than this alkene, this substituted alkene. And so as a result, this guy's not going to want to react until all of the ethynes around have already reacted and done addition reactions with bromine. So what does this look like on paper? I can tell again that it's going to do an addition reaction rather than one of my other types, because the things that I'm starting with are an unsaturated hydrocarbon, right? Ethyne is unsaturated, and I have bromine, which is diatomic, Br2. So don't forget that guy's diatomic. So my reactant side is going to look like this. I've got my ethyne molecule here. I've got my bromine, which again I've written out as Br bonded to another Br to make it more obvious what's going to happen. The bromine is going to come in, add across the double bond, and it's going to give us dibromoethene. So here's my ethene. The bromine has added across the double bond. One of the atoms ends up on carbon number 1, and one of the atoms ends up on carbon number 2. So the molecule then is going to be named 1,2 dibromoethene. And you notice this is the only product, right? Again, classic example of an addition reaction. Now you'll notice that our last example will pick up with the question that you might have had, which is, what will it look like if the addition reaction happens again? So if we have more bromine around, we react all of our ethyne away, now we're left with the reactants bromine and 1,2-dibromoethene. They can react together again, and they can do another addition reaction. And that's the example we'll look at now. We've got 1,2-dibromoethene. It's still unsaturated, so it's still a good candidate for an addition reaction. And if we have more bromine around, it can add again in another addition reaction. So if this bromine comes in the correct orientation like this, it can break this double bond. And as it breaks this double bond, then we can add, the bromine would be sitting right here, right? We can add the bromine across the double bond, one over here, and one over here. So now my product molecule is unsaturated, right? It's down to a single bond between the two carbons. And we've ended up with two more bromines being added. And so now this molecule would be called 1,1,2,2 tetrabromoethane. So here's our reaction on paper. We have our 1,2-dibromoethene, we have our diatomic bromine. Just like we've seen before, the bromine can add across the double bond. The bromine can add across the double bond, like this. And our product now is going to be unsaturated, so there's a single bond only. between the two carbons. We have these bromines on here. Hydrogens are still on here, but we now have these other two bromine atoms, one on carbon 1, one on carbon 2. So the name of the molecule then will be 1,1,2,2 tetrabromoethane.